Hello, and welcome everyone to this webinar with Solarplaza. The webinar of today is about choosing the right technology for a successful floating solar project. And well, let's get started. I will share with you our agenda of today. Well, my name is Manuela Hartung. I'm a project manager here at Solarplaza, and I'll give you a short introduction of who we are and what we do. And we'll have today the moderator of the session, Stanislas Merlet from Multiconsult. He will be moderating the session. And we have, of course, Ciel Terre giving us some nice insights of right technologies to choose for your floating solar project. And we'll have the webinar divided in two parts. So we would like to ask you to also, after each part, we'll have a Q&A session. So during the presentations of Olivier and Vincent that will be presented from Ciel Terre, I would like to ask you to already send your questions because we'll have a Q&A session moderated by Stanislas right after each part. So that is our agenda for today. Just a short introduction about Solarplaza. Well, we are Yes, there we are. So we are a events organizer, a global events organizer, and our mission is to positively impact the world by accelerating the sustainable energy transition. And we're established since 2004. We are based in Rotterdam, the Netherlands, and we have done over 150 events worldwide. So we also publish resources, and we try to share a lot of knowledge in the PV sector, such as this webinar of today. So not only an events organizer, but also at Solarplaza during the pandemic, we did not sit still. So we created three different business branches, which well, one of them is the Solarplaza Consultancy, in which we offer solutions and consultancy for new market entries. And another branch of our business nowadays is the Solarplaza Academy, which you will see in the next slide coming in. So the Solarplaza Academy is dedicated to offer training to to experts and to people trying to enter the market, the solar market. So we offer training and we offer solutions also for new markets. And well, we have not only the Solarplaza Academy, which you can see this short slide, but we also have created the Solarplaza Foundation, which is just a foundation dedicated to accelerate the sustainable energy transition for all. So thinking of other countries that are not so privileged, we also try to help with accelerating the transition of energy over there. So this is about us. I would like to share some practical notes with you also regarding this webinar of today. So like I mentioned before, we have the webinar divided in two parts. So the first part, we have Olivier and Vincent from Ciel Terre presenting, and the moderator Stanislas will moderate the questions coming in. So during the presentations, please send already your questions, the same for the second part, and you can use the Q&A box that you see beside your chat box, so you can send your questions over there. If you have any technical issues, the same box applies, so you can use that one as well. And as always, the recordings and the presentation slides of this webinar will be available for you 1 or 2 days after the webinar. So without further ado, I would like to introduce the moderator of the session today. Stanislas, if you're there, you can already come to the screen. There he is. So Stanislas, he is a senior solar consultant at Multiconsult in Norway. He has over 10 years of experience, and he has a lot of international experience as well, from different solar projects ranging from Eastern Southern Africa to Central Southeast Asia. So a very impressive experience. And he is currently undertaking a super interesting PhD study together with Multiconsult and the Norwegian University of Science and Technology on the design and optimization of hydropower connected floating solar PV plants. Stanislas, thank you so much for being with us today.
Thanks, Manuela.
Thank you so much. Well, I'll pass the words to you. And yes, thank you so much. And let's get started.
Yeah, let's get started. Hello, everybody. Welcome. Good morning. Thank you for joining us in this very interesting webinar today. We're going to have with us two very interesting speakers from Ciel Terre, Olivier Philippart if you're here, Olivier, you can turn on your webcam. Thank you. So Olivier graduated in engineering in 2004 and finance for executive in 2018. He's been in the energy industry since 2012, first at SBM Offshore. Oh, here we go, perfect. And he joined Ciel Terre in 2017. He's now the Hydrelo Division co-director. Welcome, Olivier. We have also with us Vincent Grumetz. Vincent, if you're here, you can turn on your webcam too. Hello. He graduated from both mechanical engineering and international business. He's been export sales manager in the company EMEA Technology, and then sales director in Pronal before joining Ciel Terre as EMEA Managing Director last year, or about a year ago. Welcome, Vincent. Again, I just remind you that we're going to have a Q&A session in the middle of the presentation, so please send your question in the Q&A box as it comes, all your burning questions, so we can take it. And without further ado, the floor is yours, gentlemen.
Thank you very much, Stanislas, for the introduction. Good morning, everyone. So the title, the subject of our presentation today is choosing the right technology for a successful floating solar project. Let me quickly introduce Ciel Terre. So Ciel Terre is the pioneer of floating solar. We started this activity in 2012, and we installed the first project in 2013, a 1 megawatt project in Japan. So Ciel Terre now is, in a nutshell, with three figures, it's 240 projects in 30 countries, 610 megawatts already installed with our technology, and more than 600 megawatts of projects under construction. The biggest project being 88 megawatt plant on a protected shore lagoon in Taiwan. We have 13 local teams in 13 offices where we offer a turnkey solution. This is why we have so many offices. We are close to our clients. We offer turnkey solution from pre-engineering studies to installation and O&M. We take care of the floating part, basically. So our 240 projects are spread over a diversity of sites, from irrigation ponds. This is one of the first projects that we did in Taiwan, and that's where we started in Japan as well, up to near protected shore, the project of 88 megawatt I was mentioning, without forgetting the quarry, the mining lakes, the hydro dams. All the different sites have different characteristics, and what we will be discussing today is how to segment all those sites and how to provide the best product and the best solution for each of your sites.
Okay.
So I leave the floor now to Vincent.
Yeah, so first of all, good morning, everyone. I'm very glad to see that there is so many people with us this morning. So it means there is a huge interest towards the FPV. Now we're going to talk about the market segmentation. Olivier, if you can go to the next. So actually we are divided the type of reservoir into 5 main parts. All of them have some very specific characteristic, and at the end specific challenges for the floating platform. So if you go to the next, Olivier. The first type of reservoir would be what we call the static freshwater bodies, where we would mainly find irrigation ponds. And actually this is where we started developing our project 10 years ago, because that kind of reservoir is quite, let's say, quiet. So it's not that deep, you don't have so many waves. So let's say this is the easy part or the easy reservoir for FPV. So nowadays, yeah, we got roughly close to 200 megawatt peak of capacity installed on that kind of reservoir. The next one would be what we called inner water, where we will put the quarry lakes, again, some irrigation pond and water treatment pond. Here we have a more challenging application where we can see bigger waves because of the distance between the shore and the platform. And also we can go much deeper. We saw some project where we had to go up to 50 meters. But if I talk about Europe, I would say that this is one of the most important or more developed application for us. Next. So the next one will be about hydro dam, where our large inner water. Here there is a huge potential all over the world to make a combination of floating PV on hydro dams. But again, there is some very high technical challenges because of the water level variation, and also because of the depths that we have to go to place the anchor. So right now we don't have, we have something around 5 megawatt installed on hydro dam. Yeah. Next. The next one will be the near protected shore, where we will find lagoons or bays. As Olivier was saying, nowadays our bigger project is installed on such a reservoir, such a body, with a 90 megawatt project installed in Taiwan. Here, one of the challenges is about the seawater and the corrosive environment that the FPV has to face. The last one will be offshore, but we're not gonna really talk about it today since in Ciel Terre we didn't really investigate that market, taking into consideration that the challenges will be very high and it's not a top priority right now for FPV. Okay, next.
Thank you, Vincent. If you have any burning question, please send it now so that we can answer it in this first Q&A block. In the meantime, Solarplaza, if you would mind to launch the poll, we have some questions for you. Where do you believe FPV has its greatest future potential on this presentation? So we just talked about static small freshwater bodies, about inner water, dam reservoirs, or near protected shore. So please vote on that. And in the meantime, if you have questions, also put it in the Q&A box. I maybe have a short question for you, Olivier and Vincent. I see that hydro dams, and you mentioned technical issues, but you only have 5 megawatt installed on hydro dams, which is then definitely not your core market. What is the main bottleneck there? Do you think it's regulatory or on the business case? Do you have any input on that?
You mean why hydro dams are not taking off quickly?
Yeah, I mean, Vincent, you said it very clearly. There is a lot of interest globally on putting floating solar on hydro dams, and we've been talking about that for years also in the industry, but it takes some time to come. Yeah. What is your input as a supplier perspective?
Do you want to answer, or I will, Olivier? The thing is, when we are talking about hydro dam, we have a very deep water, so we have to go very deep to be able to install the anchoring part of the platform. So obviously it has a big influence or a big impact on the capex of the project. And at the top of that, since we are on very large reservoir, then we have a fetch. A fetch, as I said, will be the distance between the shore and the platform. And the fetch combined to the wind will give some very big waves. And so at the end, you've got some big challenges in terms of fatigue resistance on the FPV. And so what we would recommend when we are talking about them is to use what we call a wave breaker to really get this wave effect going down and to reduce all the loads which will be applied to the floats. So these two combinations, the environment makes the capex higher on them, and at the top of that, you got technical challenges that you have to take care of if you want to get a reliable project which will last 25 years. Yeah.
Yeah, makes sense. We have some questions coming. Oh, here are the poll answers. Well, that's interesting. Dam reservoirs is clearly of interest here. 46%. Yeah, that's great. We have more questions coming. First one from Mohamed Boukobsa. What is minimum size required for small ponds? It's from Algeria, apparently. Do you have any minimum size to implement projects?
The thing is, we can install FPV on almost every kind of reservoir, but at the end, there is a question of, again, of capex and return on investment, and so we would say that minimum would be like 1 hectare would be the minimum size to be able to install something around 1 megawatt. But it could be smaller. It could be smaller. It's really related to the business case of the customer.
Yeah, that's great. I'm sorry for the audience. I don't think we're going to take all questions, so I just pick some here. Can you please give some idea on earthing systems?
On earthing systems, electrical earthing systems.
Yeah, for floating solar. Is it a technical challenge?
We don't see. We don't really see earthing as a technical challenge. What we do on projects, we do the same as what is done onshore, on ground, which is that all the panels are put to the earth, and the earthing cable is coming back to the shore. So we basically treat that issue the same way as ground mounted is treating it, to avoid too many questions.
Yeah,
I would say.
Okay. We have a question in dry areas in nearshore applications. What are the main aspects to consider? And the people asking the question mentions slopes, frequency, the seafloor, geology, the anchoring. What are the main components of your technical study for nearshore applications?
It's a great question, and so nearshore, in the case of the 88 megawatt project, we just discussed, and we will be talking into more details later. This project has two main challenges. The fact it's on seawater, you have corrosion, much faster corrosion than what you have in traditional freshwater bodies, of course. So you have to adapt the metallic parts. That's it's a bit obvious, but it requires some testing and some solutions to be specifically developed for that. And then the second challenge on this project was the fact that you have the tide coming up twice a day on the project. So it means twice a day the platform will go up and down, and will lay on the floor, will strand on the floor twice a day. So it has, of course, implications on your structure has to be well designed to be able to strand, and so you have to study first the topography of your reservoir, and then of course the anchoring has to be adapted accordingly to make sure that you have tension whether you are at low level or whether you are at high level.
What about biofouling? Do you have experience with that already?
Yeah, it's a good question. Yeah, it was a subject at the beginning, but in the end, because the tide is coming up twice a day, and the floors are standing. The floats are standing on the floor twice a day. We don't have biofouling developing below the floats. It could be the case where when you have a project where you don't have this tile issue, but the fact that the floor is coming up every day, it will remove the small biofuel incoming.
Okay, okay, interesting. We have a very typical question. What are the difference in operating temperature between the floating PV and ground-mounted PV? I guess it's always very location dependent, but what is your experience in gains from cooling effect and all of these questions?
It's a very regular question. You know, everybody is wondering about what is the cooling effect of FPV and what kind of advantages it brings to the project. The thing is, we don't make a formal answer to that question because it's really site dependent, and there is actually no real analysis of what is the cooling effect and what kind of advantages you get out of it. Right now, we have a pilot project in South Africa with one of our partners who is trying to do it. Really, you know, everything is installed. The module are on water, the module which are on ground are exactly at the same height, same orientation. There is also monitoring tools or devices to be able to collect all the information and really to check what is the result of FPV compared to ground mounted. But again, this will bring an answer to South Africa, it's Cape Town, but will it be the same answer for France, for Europe, for Asia, for the US? I mean, we would have to do the same experimentation everywhere. So right now, people are saying, I mean, if we get the information from all the studies, and we would have to go more into details about how the studies have been done, that the additional output that you get with FPV would be situated between 5 and some people are saying up to 15%, but I believe it's quite a lot.
Yeah, well, I guess the conclusion is look at research. So it's a lot of ongoing work on that. So yeah, it's coming. Great. We can, I see the time is flying. We take a last one before going forward with the presentation, and we can maybe take some of the questions that you have sent at the end of the second Q&A session. Interesting question here about warranty. What is the warranty years for FPV system in normal water compared to salty water? Do you provide the same warranty on the floats?
Yes, we do provide the same warranty on salty water as on normal water. I mean, the floats themselves are not concerned whether it's salty water or whether it's fresh water. It's HDPE. It's made of HDPE, so there is no corrosion. The only matter is the fixation system and the anchoring system, where you have metallic parts. But there is a lot of track record in the oil and gas and in the marine business with regards to corrosion in salty environments. So it's a matter of taking the good lessons learned from these industries and to adapt them to the FPV. So yes, we provide the same warranty.
Yeah, right. Okay, we take the next questions later after the rest of the presentation. So floor is yours again, Olivier.
Thank you, Stanislas. I'm having the turn now. So now that we've explained the FPV segmentation, we want to, basically define for FPV. Just to set the scene, rigid structures are structure on top of floats. So that's what we will call in the presentation rigid structures, and flexible structures are mainly float systems that will do the supporting of the panel plus the structure itself with a metallic fixation system. So what are the advantages and drawbacks between the two technologies. This is the topic of our presentation today. Let's focus first on the advantages of on the advantages of the flexible technology. So we have less land preparation, we have easier salty water compatibility. We already touched base on that. We have stranding, which is possible. That's what we also discussed with the project in the near protected shore. It's better designed for long waves, and it has better aerodynamics. And I will explain further all those points in the coming slides. So first, less land preparation. There is a constraint from some of our customers. Sometimes the banks are very narrow. The access to the sites is very difficult, and flexible technology can accommodate any type of banks because it requires a very easy and simple mounting platform. So there is much less preparation. If you need to install floating PV on a reservoir which has very difficult accessible banks. The second advantage, of course, is the impact on the banks. You don't have to dig, you don't have to prepare your banks, so you can bring your mounting platform, and basically when you will leave the site after the installation, the site will be as it was before. So it's also and we know that environmental studies are really concerned about what will be the impact for the fauna, for the flora around the lake, not only on the lake, but also around the lake. If you have nesting species around the lakes, it's a very important topic. And when you come, during the right season, when you have nesting species around the lake, you come with this light platform. When you leave the site, there will be no change between before and after. So that's a very important advantage of the flexible technology. The second one we already discussed is the salty water compatibility. So not much to add than what I said before. HDP is not sensitive to salty water. So what you have to do is to adapt your fixations, to adapt your mooring, and it requires design, it requires testing, and it requires know-how and experience, basically. So a focus on the salty water case study. So the 88 megawatt project in Taiwan. So we talk about 280,000 solar panels. So it's a lot. It's 86 hectares, 72 hectares for the FPV island itself, so we use the Hydrelio Air 5-degree technology in a 2-in-a-row configuration. And what I explained before is that the focus has to be on corrosion and on stranding of the structure on the ground twice a day because of the tide which is coming up from the sea. So it's protected by a jetty, but the water goes in and out as if you were on the coast. So there are less waves than what you would get on a near shore without any protection, because the waves are only created by the fetch, but you have the tide coming in and out. So it's a good transition to the next subject, the stranding. The ability of flexible is to be, of course, flexible. So when you're considering a floating solar project to be where during the lifetime you will have the possibility to lay on the ground, you must make sure that two issues are tackled properly. One is the topography of your reservoir when it gets dry, to make sure that there is no bumps, that there is no stones, that there is no accidental, that there is no very sudden raise of the topography, the ground relief, as we call it. And the second aspect is of course the anchoring. You have to make sure that your anchoring will allow the structure to go down and to go up. It's not exactly specific to when you have stranding, but it's a bit. I mean, the water level variation issue goes to its maximum because it can go from 0 to whatever is the depth of the reservoir. So the anchoring has to be adapted for that. Regarding the design for the waves, the flexible structures are really adapted to long waves. I will show you a video just after where you can see that the structure is following the long waves. Where you have to design a wave breaker, as Vincent mentioned earlier, is for the short waves. The short waves will give, because they are very frequent, you don't need much wind to get small waves. They are very frequent, so the fatigue will be important due to those waves. So you have to cut the short waves with a wave breaker, but the long waves, which are created by high wind, are not an issue. You can see here. So on the right, you have the behavior of a rigid structure with waves. So you see that the structure is not adapted. So you can imagine the loads that are created into this structure because of the waves. And then you see the flexible structure, which is following the long waves, the waves with a long period, which are not an issue. And it's good news because it's much easier to cut the small waves with a wave breaker that is on the surface than to cut the long waves. To cut the long waves, you have to install something much deeper and much bigger. So it would mean almost installing a concrete barrier. I mean, so this is why we believe that flexible solutions are more adapted to big sites because they are more adapted to long waves. The last key strength of the flexible technology is the fact that there is less environmental loads, less height above water, so less wind load. It's physics. It follows the waves, so less hydro loads, and less draft, so less current loads. So at the same, if you have the same tilt of the panels and the same configuration between a flexible and a rigid structure, you will have less environmental loads on a flexible structure, which is an advantage for the anchoring. And final slide on the dam case study. So the dam is basically gathering three issues, as Vincent mentioned at the beginning: the water level variation, the depths, and the waves. So we had the opportunity to install a first dam project in 2016 in Alto Rabagao. So it was 5 years ago, and since then we have learned a lot on the fatigue issue. We have been able to correlate the data from the site with the models that we are setting up for the deformation of the floats and the tests that we are doing in our lab, in our own lab. So now that our fatigue models are properly correlated, we are able to design the perfect wave breaker for each project depending on the site data, and to make sure that when we go to large projects on dams, the structure is well designed for to sustain for 25 years on such dams. So now it's the time to accelerate the dam projects. We are ready to tackle them, and so we hope the dam projects will take off soon. So now I will I will leave the floor to Vincent to present the advantages of the rigid technology.
You're on mute, Vincent.
Yeah, thank you, Stanislas. Yeah, talking about rigid technology, what we could notice is that rigid technology are good for adaptability to the PV panel size, and I will go more into details about that. The density also, because there is always, when talking about FPV, it's always a question of designing the right island suitable for the site, and density is one of the factors that we have to consider. The snow load resistance. Also, if we want to change the tilt of the module, it could be easily done with a rigid structure, and at the end, in terms of cable management, there are some advantages of using a rigid structure. Next. Yeah, so if we talk about the adaptability to the module, or to the size of the module, what we could see, or what we could notice on the market, is that the size of the module is increasing a lot over the years. So when we are using a flexible structure or flexible technology, it's usually one float equals one module. And so if you want to follow the trend of the module, it means that you will have to get bigger float to accommodate with bigger module. And while using a rigid technology, because we spread the weight of the module all over the structure and then on the float, it's easy to accommodate to bigger module size. So this is something right now, if we talk about the flexible structure, we can go up to 600 watts, something like that. But if we think about the next technology of module, which will go above 700 watts, then a rigid technology will be more convenient, I would say. Next. Then one criteria or one requirement while designing an FPV island is the capacity of the island itself. And so there is always a question of density, and depending of the strategy of the developer or the IPP, it could be either we increase the capacity of the project, or I mean in terms of watt peak installed, or really trying to increase the performance ratio of the project. And when we talk about rigid structure, because the modules are very close to each other, and there is no gap actually between the module, we can increase the density by using rigid technology. And also we can make, as you can see on the picture, this is a duo pitch, so I would say an east-west configuration, which is very common with rigid technology. And so by doing so, you definitely increase the number of modules that you are installing, because they are again very close to each other. And so yeah, this is, let's say, but yeah, this is the best way of getting the higher watt peak installed on the project. By the way, this is something that we can do also with flexible technology. Next. One of the advantages of rigid technology will be the snow load resistance. We can see that for very extreme condition, we can easily increase the buoyancy of the project with a rigid technology. So in fact, we can multiply the number of floats which is below the structure to increase the snow load resistance. With metallic structure, we can go up to 2.4 kilonewton per square meter. When usually what we can see with flexible technology, we can go up to 0.5 kilonewton per square meter. So it will be around 5 times more for rigid technology. Yeah, click again. Just some example of some snow resistance tests that we have done over the years. As I said at the beginning of the presentation, when we started the FPV, we went on, let's say, the easiest reservoir, but we can see that there is more and more interest for more extreme condition reservoir. And here you got 3 examples of, let's say, test bed that we've done over the years. So we got one in Colorado, where we have a big amount of snow coming every year. One in Korea for a bigger size, and a small project in Sweden. What we can say at the end is that for a question of rigidity of the floats themselves, the snow and the ice are not affecting the quality of the material. Also, the HDPE working at a very low temperature is completely compatible. And so what we did with that project is that we monitor every parameters of the project to get as much information about the behavior of an FPV project with snow and ice. Something else that we can easily adapt with the rigid technology is the tilt. As I was saying while talking about density, we can easily make view pitch, but we can also increase easily the tilt of the module. For a question of yield, of power generation, sometimes it could be better to use smaller capacity with higher tilt, so increasing the efficiency of the module. And at the end, you have a specific production, meaning kilowatt hour per kilowatt peak, which could be bigger. So it's always a question of compromise between the capacity you install and obviously the power generation that you create. And by using a rigid technology, you can have a very low tilt, like a very high tilt. But of course, when you are changing the tilt, you have to be careful of all the wind loads which will go on the module, because at the end, the loads in general will be completely different if you increase the tilt. And the last one is about the cable management design. When you have a rigid technology, you can easily integrate the cables into the structure. So when we talk about flexible technology, we have to be very careful about the flexibility of the cables, the slack that you give between each module and so on. Here, because it's rigid, it's not moving that much, so you can easily integrate them in a fixed position. But still, you have to think about the cables which will go from the island to the shore, to the banks, because that cables will still have to move during the lifetime of the project. And on the main cables, you will have to be careful of the flexibility and slack that you will use. Okay, next. So as a conclusion, what we would like to say is that there is many kind of reservoir types. Every reservoir is pretty unique, and there is no good, or there is not a unique solution for each reservoir. There is plenty of technology available on the market, and at the end, they are not competing against each other. They all fit to one purpose. And that's something that we could notice on the market, and something that we want to insist on.
Thank you.
If you have anything to add, Olivier, about conclusions?
No, I think you mentioned the main points. As I said at the beginning of the presentation, we have local teams everywhere in the world. We have 13 offices, and we are always here to help you and to assist you in defining what's the best solution for your project, taking into account all the parameters. We've been in the business since 2012, so we've overcome most of the challenges. We are here to help. Anything you want to ask, please do so.
That's good, because there is a lot of questions. but we're running a bit out of time, but we have to take some anyway. I'm just going to take 5-10 minutes. I hope it's great for you, the attendance, and for Solarplaza. I guess the burning one, and that was a question I had too, is you're comparing rigid and flexible systems, but is Ciel Terre providing rigid systems, or are you looking at developing this kind of systems too? Because it's a bit unclear from the presentation.
Yeah, of course, yeah. Ciel Terre, obviously, you know, we are investigating all kind of systems, you know, we are definitely investigating the fact of developing rigid structure, but when we talk about rigid structure, it doesn't have to be steel, you know, it could be other kind of material as well. The thing is, from all the inquiries that we have, we can notice that people are really, you know, making kind of a competition between rigid and flexible, and so our focus was to make a general comparison, you know, but nothing. Yeah, this was a general comparison about the two structure. Yeah,
that was great.
Yeah, and for us, it's. I mean, again, that was the purpose of our presentation, is to say that the two structures have different advantages, and some are more adapted to certain sites, and the other ones are more adapted to the other sites. So, so yes, we are looking at the whole FPV market. So we cannot ignore the advantages of the rigid solutions for some of the sites.
Yeah. Are you only including rigid versus flexible, or are you also considering this membrane-based solutions, or a bit more out of this binary industry here? Could have some advantages for specific locations, specific conditions.
Yes, true. We didn't study this technology, the membrane one. So this is why we didn't include it into the presentation. But of course, I mean, if this technology has been developed, it has advantages for some of the sites, maybe the sites that we didn't mention, the offshore ones. So I guess it's also one of the technology that should be included when you compare the different technologies for different sites.
Yeah, and talking just to add something, talking about the offshore, we didn't talk about it just because we really believe there is quite a lot to do with let's say inland reservoir or near shore, that we didn't go into that direction yet. Yeah.
I can only agree on a personal level that the offshore industry, or the offshore market or segment, is something else.
It's something else.
That's great. There are a lot of questions about environmental and social impact of floating PV, and maybe we could tailor it in a way that, are there any advantages and inconveniences with both of these technologies, flexible and rigid? Is there any difference in the impact of life underwater? There is a question about microplastics, for example. Is it something that you've been studying for the flexible solution?
Yes. So taking the subjects into order, the difference between flexible and rigid structures for environmental issues. The first aspect is one that I mentioned, is the land preparation. Is much less consequent when you have flexible structures, because you require much lighter platform to install your FPV projects. But when talking about the water itself, I think it's more depending on the PV configuration. for example, if you have duo pitch that you can do on flexible and that you can do on rigid, you will have a much more coverage ratio. And typically you want to install those projects on reservoir where you don't have space. So you will have less light coming into the water. So there will be an impact on that aspect. And then what was the last question on the environmental subject?
Because there is a question about microplastic abrasion
yes,
of the plastic floats, for example.
Whether it's flexible or whether it's rigid, we are talking about plastic floats. So I mean, less plastic floats on the rigid ones, but the contact with water will be plastic anyway. And here we are talking about HDP in both cases. HDP with adequate UV protection, and if you have adequate UV protection, there will be no degradation. So here it's a matter of having the correct additives into the plastic to make sure that in the lifetime of the project you will have no degradation because of UV.
Yeah, that's great. There are also questions about materials that you use, other than HDPE, while we're at it. In terms of the metallic parts, for example, is it designed with stainless steel, aluminum? What kind of coating do you apply to protect against corrosion? Can you give some ideas about that?
Yeah, I mean, for the flexible solution, it's mainly aluminum. So for aluminum, you don't need any protection. Aluminum will not degrade in salty environment or in freshwater environment. Then it's a matter of selecting the right fasteners, because the fasteners will be made out of either aluminum or steel, depending on the load. And then it's also a matter of galvanic corrosion between the aluminum and the steel, where you have that you must take into account to make sure that you have no contact between the two to avoid any galvanic corrosion.
Yeah. Do you have any solution for floating transformer stations?
Yes. Yes, we do.
Yeah.
I mean, we are currently developing one barge. Actually, we did it in the past, not with a power transformer, but with the inverters, and we are going to the next step because the size of the project is increasing. So now, for some project, it makes sense to be close to the island. And so we are developing a barge, and it will be a barge for the power transformer, which will be available by beginning of next year. Yeah.
Great, super.
But what we are saying for quite a while is that as far as we can keep the electrical equipment onshore, it's easier for a question of maintenance and operation. But then it's again a question of compromise of what is the efficiency of your platform, of your project, compared to the OPEX cost, you know. So it's always a question of compromise and strategy from our customer.
Yeah. Of course. Yeah. What are you looking at other solutions? Are you also considering tractors on floating structures?
No, I mean it's not something that we are looking at now.
Okay, that's a clear answer. Yeah, great. There are a lot of questions about tilt and wind speed that can Ciel Terre handle. If you want to just comment on that or remind the audience, where are your limits in terms of wind loads, wave loads, and do you have any numbers that you can throw out in the air?
Vincent, I let you.
Yeah, regarding the wind speed, Our design is done for a wind speed up to 200 kilometers per hour. This would be the maximum wind speed that we can handle. And regarding the waves or the movement, we would say that the nominal wave height that we will handle will be around 1 meter. But again, case by case, we will study the wind loads that the site will face. According to the design of the island, we'll check what are the loads applied to the floats, to the mooring line, to the anchors. And what I'm giving you, I'm just putting some numbers in the air, as you say, you know, but it could be less on some specific location, and it could be more on some other, you know. So it's really, but in average, this would be the number that we can say.
I think it's great to just give an idea. Interesting question here, and I think it's going to be the last one. Have you studied the difference in mismatch losses between flexible solution and rigid solution? We could expect rigid solutions to have less mismatch losses, which are due to individual panels moving individually from each other. Is that something you've been looking at?
I mean, there is a study from Ceres that was nicely made on the mismatch losses, and I think we are taking that into account when we do our designs and when we consider the power output. But we've not done our own research on that topic. We rely on very experienced labs like Ceres. They've done a great job on that, so no need for us to do it twice.
Yeah, well, thanks. Yeah, I think it's time to wrap up a bit. If you have a concluding word, please feel free to do it now. If not, I will just give back the floor to Manuela for just to say goodbye. I want to thank the audience for very interesting questions, and thanks for attending. That was great, very interesting. So yeah, Manuela.
Thank you, Stanislas. Yes, we had an amazing amount of questions, a lot of questions. So we unfortunately cannot answer all of them because, of course, our time is limited. But we'll make sure to send all the questions that were not answered to Vincent and Olivier, and also to Stanislas, so that you guys can also address these questions later on. But I would like to thank you, Vincent and Olivier, for the amazing insights you gave today, and Stanislas for moderating these nice Q&A sessions. Thank you so much for everything today, and thank you watching us. Don't forget, we sent the recordings and the presentations also 2 days after this webinar, and stay tuned with Solarplaza for any more updates on floating solar. So thank you so much, gentlemen, and yeah, I wish you all a good day. Thank you.
Thank you, Manuela.
Thank you very much.
Thanks, everyone. Bye-bye.